Good afternoon, everyone. I'm really chuffed how many people have chosen to come along to this breakout session event. Is it only because we were running it once? Thank you, everyone, for joining this breakout session hosted by my organisation, UK Steel, which is the sector association that represents the steel sector in the UK. I'm Gareth Stace, I'm Director General of UK Steel, and I'm chairing this session, A Material World. And there's no real need for an introduction, really, from me, because you've kind of probably worked out that we've written all of the speeches that have already been said today with the speakers, because they've all mentioned the issues that we're talking about now. And therefore that, I hope, shows that we as the steel sector have our finger firmly on the pulse. And we're very keen not to do a session which is the steel sector talking to the steel sector about steel, hence why we're talking about the wider issue of materials today. And it's really important at the moment, more than ever, and I know I've been talking about critical materials and rare earths for ages and ages, but over the last 2 years, what we've really seen, haven't we, is the fragility of supply chains certainly with COVID and the pandemic, and getting over that is taking much more time than I would have thought, and now the war in Ukraine. And so I think it's not just a blip. This might be a prelude to what's going to happen in terms of materials and our different focus and clearer focus on materials going forward over the next 30 years. There is a need for sectors like steel and other metals and cement to look at our emissions and reduce our emissions going forward. Also a need for, or a requirement for, consumers to be purchasing products that have less emissions but also will be more expensive, which I think is not seen so much. But an interesting one, and I'll finish with this before I introduce the speakers. An interesting one is there's a study by McKinsey this year, and I find this really incredible. A study by McKinsey showed that per unit of energy output, wind power was around 2.5 times more material intensive than gas-fired power generation, and almost 5 times more than coal. So as demand grows for low-carbon materials, driven both by, as I said, the consumer choice and government regulation, there will be impacts on prices, certainly availability and supply of these raw materials. So we have 3 experts from academia and industry today, and I'm really delighted to welcome all 3 of these speakers. We're really pleased to have them. So we have Professor Cameron Plydell Pierce, who's the Deputy Director of Sustain from Swansea University, Dr. Jose Hathvedo, who's the Research Associate at the Resource Efficiency Collective at the University of Cambridge, and then lastly, but certainly not least, we have David Mason, who is Head of Environment Technical at Skanska UK. And so what we're going to do is each speaker is going to speak for perhaps 12 minutes, 12 minutes exactly, and I will cut them off if it goes beyond that, because what we really want to do is have the 3 speakers speak, and then there'll be a Q&A session afterwards, and we've got a real tight deadline at the end, because you've all got to stand up and go to a different breakout session once this finishes, so we've really got to be on time here. So without further ado, I'd like to ask Cameron to kick us off with his presentation, which is Steel as a Decarbonisation Vector, the 1 billion tonne challenge. Thank you.
You might think that I changed my name by Deepole just to screw over Gareth, but unfortunately I was born with it, so there we go. Lesson number 2 of my talk, never invite an academic to give a presentation and then tell them they don't have very long, but I'll do my best. I think I've already been introduced. I work on a program called Sustain, which stands for the Strategic University Steel Technology and Innovation Network. We made up all those words so that they make the right word for us in the end, of course, like everybody does. That's the largest critical mass activity supporting fundamental research for the steel industry that's ever been funded in the UK. We're not the only players in town, so there are other projects supporting the wider foundation industries at universities as well. and they include the Transforming Foundation Industries initiatives. I'm involved personally in the Network Plus. There's also a Transfire research programme, and there's also UK Fires, which is where Jose works as well. So there's a wide area of opportunity, and the steel industry is actively engaging with the university sector to solve fundamental long-term research challenges in and around the areas of decarbonisation. Much to my disappointment, I don't have time to explain to you how great I am, which is what academics normally like to do. So I'm just going to have to redirect you to the website so you can find out on your own. So I'm going to try in this talk to go through context as quickly as possible, which involves some of that internal stuff, looking at the steel industry and what the steel industry can do, and then hopefully spend most of my time talking about what that means for the people who actually use the products and how things are going to change and how we can help each other as users and producers of steel to decarbonise the manufacturing economy in the UK. So I'm going to present my three crises. I've been presenting these since about 2018, finding people become more and more interested in them the more you present them, and they seem to become more and more prophetic as I go on and self-fulfilling, which is anything a bit worrisome for me. So the first UK crisis was already highlighted earlier on by Jonathan Reynolds. He said we need to think about our emissions in terms of consumption rather than what we generate territorially, and you can see that consumption emissions sit way behind what our production-based emissions are, and these figures themselves don't include actually steel. So it would only get worse because we import a lot of things that are made of steel. The policy implications there are, of course, something like a carbon border adjustment mechanism, and what's that going to mean for the people who have to use the materials to make products. The second crisis that we have is waste. We're producing a lot of waste. Everybody, as their economy gets larger, produces more and more waste. But in the UK, we've got a particular problem with that because we like to offshore that problem, like many of our other problems. And unfortunately, nobody's taking it anymore. So what are the policy implications for that? Well, we've got a right to repair coming down the track. The EU are already looking at their waste regulations and how they regulate the import and export of end-of-life materials. And the Chinese National Sword Programme has scuppered us in terms of just shipping off all of the stuff that we can't recycle, like this residual waste that comes out the end of our recycling processes. And the steel industry can help to do things like that. And of course, as we've already mentioned, in terms of critical raw materials, ironically, we're producing a mountain of phones that contain critical raw materials, but we're also trying to get rid of them because we don't know what to do with them, even though they contain the elements that we're ultimately going to depend on. And again, the UK steel industry can provide the economies of scale that are required to recover those because they're interested in the high volume of material, of iron material that sits in those waste streams. And then if that wasn't bad enough for those two, we've also got an energy crisis. I think now, before I was explaining this to people, now I'm not even going to bother explaining this slide because everybody knows what the challenges are, except for to say that electrification is a byword for decarbonisation these days. So basically what we have to do is we have to take the blue line and the grey line and add it to the red line. And if we're going to do that, we have to have a good infrastructure and we have to have reasonable price of electricity, otherwise no one's going to invest in electric intensive technologies. What steel use looked like up to now, and this is from a global perspective, the context for what we do in the UK. So in the last 20 years, we've added about 1 billion tonnes to, I don't like to call it consumption anymore, utilisation of steel on a per annum basis. And global economic catastrophes provide minor blips in that trend. Okay, most of that's been driven by developing economies, but there's still lots of economies to develop, and so the projection is that that's going to increase. The UK, even though it is a developed economy, still contributes heavily to that because our true use of steel, compared to many other economies, far outstrips what our apparent use is. Okay, so that means the stuff that we import in products significantly offsets what we're not consuming in terms of raw steel locally. What's it going to look like in the future? Well, whether you look at the sustainable development scenario or the stated policy objective scenario from the IEA, the value is going to go up. Yeah. So actually, even though we're already at close to 2 billion tonnes, it's going to go up, and it could be heading towards 2.5 billion tonnes by the time we get to 2050. So we're going to be producing more of this material. That should hopefully be beneficial because we'll be using it in technology that allow us to decarbonise, and Gareth highlighted wind power as one. What is the steel industry looking internally going to do about this? That's the question. Okay, so the summary of the content of this slide takes about an hour to present. Okay, so this isn't a summary. This is just kind of like a few throwaway remarks about the complexity of the decisions that have to be made. But you can boil it down into essentially three things. Okay, we can either continue using a blast furnace, which is by far the most productive capabilities ever been invented and the most advanced technology for producing iron and steel, bar none, absolutely. okay, with some form of CCS and CCU. You can go for an electric arc furnace, which I was going to do a show of hands, but I'm not going to have the time, is the oldest technology on this slide, by the way, and by far the most mature from that perspective. And alternative iron making technologies, which is basically some other way of producing iron that isn't from a blast furnace. Yeah. If you look at these and you compare what we're going to do against all of those, then with CCS, CCU still not proven on blast furnaces at any level of scale, maybe a 50% reduction, so we might be going down to about 0.5 to about 1.8, depending on what your original carbon intensity was, how your supply chain worked in the first place. Electric arc furnace, you'd think it would be zero if you use green electricity, but actually you still need to use a lot of carbon inside the process, which generates emissions. So if you're going to add CCS or CCU onto that to get to actual real zero, and then look at all of the subsequent processes that you have to do to get the steel into the hands of the user. And then alternative iron making technologies, both much less commercially mature. We've basically got one commercially mature opportunity, which is around DRI, and then they're looking at hydrogen DRI. There's not only a technical risk, but there's also a financial risk, because if you look at some recent papers on old money, before we went into COVID and the supply chain crises, we were looking at least doubling the value of iron units based on hydrogen production alone. Okay, so lots of uncertainty. And then in terms of scrap availability, well, of those, if electric arc furnace is the most mature, scrap availability has got to be the one that you're going to go for and look at. And scrap availability is going to increase. Fantastic. Unfortunately, it's not going to increase enough to meet the demand. And this is where this billion-ton challenge comes from. So we're going into an area where the easiest thing we can do is remelt scrap, but there isn't enough scrap available to us to be able to do that. And we've got a shortfall of around 1 billion tons. So if we're forced into position through the policy mechanisms that I mentioned earlier on, around carbon border adjustment mechanisms, to decarbonise the whole carbon footprint of our materials, of our products, including the materials that we use to make them, then there's going to be hyper competition for this material. So if it wasn't already clear, scrap is a critical raw material. Yeah, and just to prove that, a lot of the EU and China are already implementing export controls to make sure that they hold on to the materials that they already have. We're not doing that. We're exporting about 8 million tons, and that's going to cause us some problems. Okay, so what does that mean for customers? Let me move on to the customer side. So do we still need a UK steel industry? I was going to dwell on that, but I think a lot of points have already been made on that in the previous talks, so I'm not going to. Basically, it has the lowest carbon footprint, and we're looking at how we make it even lower, right? So if you're looking at decarbonising through the materials that you use, then it's a no-brainer. The answer is yes. Are they products likely to be the same as they were before in 2050? Very unlikely, because 75% of the materials, the steel grades that we use now, weren't even invented 25 years ago. What's that meant for us? It's meant that actually producing the material becomes harder and harder, because our control charts, the degree to which we can process these materials, get thinner and thinner and thinner, and it becomes harder to produce at high yield. So what the types of products that we're going to produce in the future, yeah, they're going to have to meet customer demand, but they're also going to have to be robust and differentiated. And as we move to things like decarbonised electric heating of material, offers the opportunity to harness that, and modelling as well, and the AI and the digital revolution, to be able to give more reactive processes and mass customization of the steel products. And I think this is a direction of travel. We can take all of that information and pull it into what's called a materials passport, and that's a data center that's going to follow that material around and unequivocally produce the CO2 information for that material as it goes around the supply chain, comes back from end of life and back to the producers. And if you don't believe that's going to happen, the London Metals Exchange are already doing it. Okay, so they're already implementing a system by which you can do this. At the moment in aluminium, but it will extend to other materials. What does this mean in terms of applications? How am I doing for time? Not too bad. What does this mean in terms of applications? Well, here's a couple of examples. So in terms of steel-intensive buildings, there's a project here at Swansea University that looks at how we can use steel-intensive off-site constructed materials and buildings to produce active buildings that generate, store and release their own energy. So these technologies are not incidental to the steel, but actually integrated into those products and sold as solutions. So even in their use, we can harness the intrinsic low carbon footprint of the material and then use the use phase to provide further benefit for the decarbonisation of the wider economy. and we have 2 demonstrators in South Wales that would allow us to do that. Another one that people might not be so clear is actually the electric revolution. A lot of the motors that you're driving in your electric cars, and I just bought one yesterday actually, so I'm now personally invested in this, are made possible by steel and electrical steel. So there's a magnetic characteristic to iron which is inescapable and brilliant. And as we move to switch reluctance motors, which will reduce our reliance on critical earth materials, we should be able to use more and more of those steels in those motors to drive those forward. And as they come to their end of life, we're already in a position where the automotive manufacturers like JLR and Tata are there actually reclaiming the material, taking it back at end of life with some level of provenance and information about the material that they originally supplied. So we're heading towards a circular economy. I've got 2 minutes left, so that's not convenient. And then in terms of potential drivers, something that I picked up in a recent scour for information was this OECD report on best available technologies. Why am I looking at that? Well, that's normally about industrial implementation of technologies that reduce emissions to air from an environmental perspective, but it's legislated, and this is the direction of travel. So if you look at where that's going, that legislative best available technologies, we're looking at making sure that that sits in a sensible context of the circular economy. And this is what's going to happen in terms of products and the products that you manufacture every day. Just going to skip over that one and come back to it. And then future, what's this going to lead to? Future business models. And one thing I'm particularly passionate about and is driven by Owen in Cells to Steel is a transition from a linear economy to a circular economy. Okay? And this is about how we can work together, because there's no way that the producers on their own or the users on their own of steel are going to be able to transform to fully decarbonised products with decarbonising functions. We have to do it together. And so what partner as a steel, as a product manufacturer, what partner could better suit you than the people who design the products, produce the products, to help you in managing that product, how that product performs through these inner circles of the circular economy, which is where we want to stay for as long as possible, okay? And the last point that I wanted to make on this is around skills, and then I'm definitely done, Gareth. It was made, I think Andrew Neil made the point this morning about the war on talent, yeah? There just aren't going to be enough people to help us who understand enough about these materials to make sure that we carefully circumnavigate these inner circles. We're going to have to do it together. Why would you go out and try and compete with that resource and that information and those skills and that knowledge with a company who's producing the materials for you? Because if you collaborate with them, that knowledge is already there. The steel industry is already investing in its skills for the future. And if you work together, we're going to see a real benefit for the future of the UK economy. So that's my pitch on at a high level of how we think this can work. And I think Jose is now going to provide a little bit of detail about what that means on a scrap supply chain basis for the UK in particular. Thank you very much.
Thank you, Cameron. Actually, you've just saved some time because you didn't need to do. I don't need to do the introduction to Jose now. You've done it. Thank you.
Right, so I'm Jose Azevedo, and I'm a research associate within the UK Fires project, which the main aim is really to locate resource efficiency at the heart of industrial strategy. So I'm going to talk about the high resolution map of the UK metals flows in the UK. So I made my job slightly easier than Cameron's because I'm just focused on the UK. So it's not a 1 billion ton challenge. And I'm also very grateful for the help of all of my co-authors. Most of the work that I'm presenting today is the combination of roughly 2 years of research. So from our point of view, the real big challenge is climate change. And I don't need to tell you that we have the Climate Change Act that tells us that we'll have to get emissions to zero by 2050. And within UK Fires, 2 years ago, we've done some analysis where we've predicted how much non-emitting electricity we'll be generating by 2050. And we also estimated how much energy we'll actually need by then. And we noticed that there is a big gap. And I think Cameron also alluded to it. And one of the ways that we can shorten this gap is through resource efficiency improvements. And to do that, we need to actually understand how the whole system uses resources and how they flow throughout the various physical processes in order to find the biggest opportunities for emissions reduction. And that has been the focus of my work for the past 2 years. So, as I was saying, and this is very related to the title of the session today, which is A Material World. This is my material world, which is all the emissions intensity materials that are flowing in the UK right now. So from left to right, we have extraction and recovery of materials, and then the production of the biggest sources of CO2 emissions in the materials production, and then the use of goods. So this is called the Sankey diagram, and the width of each line is scaled by the mass of the production of the material. And we can see, and I know that David is well aware of this, that cement is the biggest product by mass in the UK. But if we think about metals, actually, it's about 30% of the UK manufacturers' emissions. So metals are actually the biggest material by emissions footprint, and this number is very important. It is responsible for around 14 million tons of CO2 equivalent. So I wanted to get a better sense of what's happening within this box called metals. So I produced this diagram, which only shows the flows of metals, so it doesn't include all the other materials. And if we look at the left side of here, we see that we are recovering actually a lot of steel, and we're also importing a lot of metal ores. But crucially, this line here is wider than this line. So it means that by metal content, we're exporting more steel than what we are importing in ores. And I did the math, and if we recycled our steel internally, we would save around 6 million tons of CO2 equivalent per year. But the really key novel aspect about this graph is actually what's happening in here, which are all the processes that transform metal intermediate goods that are the output of the steel industry into components that can be assembled. And if you look at the kinds of research products that are funded, they are looking at more cutting-edge kinds of processes, such as additive manufacturing and others. But the processes that we actually use are decades old or more, and they haven't really changed that much in the past decades. So I think there's a really good opportunity to rethink how we use these processes and try to get resource efficiency gains there. And one really crucial, important part of this figure is that we have this cycle of prompt scrap, which is a scrap made during manufacturing. And it turns out that in the UK, 17 of this metal actually never makes it into goods. And if we could reduce this number to about 5%, we would save 0.5 million tons of CO2 equivalent. So about 5% of the whole footprint of UK metals production. And the final key aspect about this graph is that most of our demands for goods is met by imports. And we know that this very well from estimates on financial data, but this is based on physical data. And you can actually see the proportions here, and it's quite striking. It's a significant amount. And this is not only assembled goods that we import. Even when we assemble goods in the UK, we are importing a lot of the components that are used in assembly. So let's try to understand a little bit more about what's happening underneath this figure by zooming in a little bit. And what this graph shows, I know it's a bit complicated, so I'll leave you some time to understand it. But what this graph shows is metals production in the UK in 2018. And we have the collection of scrap, and most of the scrap comes from vehicles of construction and demolition and waste households. And we can see this very clear white area in the graph where we have this disconnect between the collection of metals and the actual use in production. And if we keep moving towards the left, we see iron making, which is primary metals production. And we can see this very big black line, which represents the process emissions within metals manufacturing. And as Cameron pointed out, if we use the electric arc furnace, we can mitigate some of these emissions. But of course, there will be residual emissions that are also significant. And if we keep moving towards downstream, towards the left, we see that most of the metals that we use are sourced from steel, and we have some production of stainless steel and alloy steel. And then within the non-ferrous metals, aluminum is the biggest one, and it's mostly produced from recovered sources. And we have some copper and other metals production. But the bit that I'm really keen and excited about is what's happening downstream of this. And this is, again, another complicated graph, but the left part of it is exactly the same as the outputs of the previous figure. And now we have what I call production of intermediate metal goods, which is mostly rolling processes. And The key piece of insight that this graph tells us is where the scrap actually comes from within manufacturing. And we have estimated that we could save around 0.4 million tons of CO2 equivalent if we improved sheet metal forming. And this is without any new technology, just thinking about how we organized production of car components, essentially. And there's also savings to be had within design of cars and buildings. So we know that we use more metal than we need in building design, and they could be perfectly safe if we use less material. And there's really big potential to use higher strength steel within transport equipment to make lighter cars, essentially. And this would add up to a significant saving of around 1 million tons. Right. So I've told you about the current picture, and it's very detailed, and I'm planning to publish a paper on this where you can have more time to actually look at the graphs. But what can we do about this? And I think most of the things have actually been covered in the morning sessions. But I think for policymakers, it's really important to account for the total material footprint. And I think Cameron agrees with that, because otherwise imports look way more favorable than internal production. And there's a really big opportunity to save emissions there, because the operations that we have in the UK tend to be less emissions intensive than foreign operations. For material producers, I think there's a great opportunity to integrate vertically into scrap collection and sorting, because that way metal producers can now actually control the quality of the material that we recovered and produce goods with higher quality instead of downcycling metals into uses in construction. And for manufacturers, I think they need to be aware of the material utilization within their processes, and also they can design goods with less metal. What about me? What about researchers? What are we doing about this? Last month, we published a report called Materials and Manufacturing, where we've selected these key decarbonization themes, and we calculated a huge amount of entrepreneurial opportunity that can come from really taking climate change seriously and taking account for the real constraints that arise from climate change. And this report is freely available at this link. And I would be delighted if you drop me an email, and we can, if you are interested in any of these opportunities. They are big numbers. And the final thing I want to say is that we're developing a platform that essentially takes all the information I just given you in one place and would help policymakers, manufacturers, and research understand how their actions can actually reduce emissions. And thank you for listening. If you want to talk further about this, please just drop me an email or talk to me during the networking sessions, and I'm looking forward to the discussion.
Thank you, Jose. And now we move on, before the Q&A session, we move on to understand what this means for industry today. And Skanska is a leading organisation in efforts to decarbonise its supply chain. So over to you, David.
Thank you very much. Good afternoon, everybody. Yeah, so as introduced, I'm here talking from, I guess, an end user perspective, construction company. We're going to go through a number of things today, but I'm interested in getting to the discussion as well. So I am going to be quite brief. Firstly, Skanska, international construction company, Swedish-owned, Swedish orientated, around 12 billion revenue a year across 3 key market areas, residential development and commercial development, but the main and biggest area of our operation is construction, is contracting, tier 1 contractor, across all of those blue shaded areas, but that's about 85% of our revenue is doing things for other people, bringing designs to life, taking care of the logistics, the detailed design, getting all the paperwork in place, that sort of thing, which we'll talk about the implications of. So yes, Skanska set itself a net zero trajectory 2045. Had that signed up as a science-based target recently, and getting that across our geography was quite an interesting mix. There's different political outview across that area of blue shaded market activity. Importantly, though, for us, this has to include our supply chain. So we're including in that target the implication of what it takes to do our revenue every year. So the danger of doing just our direct emissions, which is actually quite a small sliver of the total pie. I think I've got a graph on it in a second, but it's sort of 4.5% of the total is what we control and influence directly. Most of what we're talking about here is how we can influence the design and the use of materials and the methodologies and the supply chain that we do over time. You'll see this busy bar chart down the bottom here shows an ebb and flow, and that is construction. That is the ebb and flow of the emissions associated with construction. A number of things drive that. The activities we're doing, the overall state of the economy. There is a thing of inflation going on there, but most importantly for us, there's a phasing of major projects and big material uses within those projects. To deal with this, we set ourselves like a 6-point plan really that we're implementing across the company, and again just trying to keep it simple. Low carbon skills and competencies, so doing as many interventions as we can, role focused training, really trying to get across the business to make sure our people understand that the size of the challenge and what we're asking them to do. Making use of carbon data, so being as efficient as we can in the collection of the information by which we make these carbon appraisals, and which we're starting to make carbon appraisals. It's an immature area. There isn't good data across the thing, and we're being asked and being pushed by customers, and we're also suggesting to customers we should be making different decisions based on this data. So how that's improved and how that's transparent is a key part of our plan. Once we've got that data, how we use it with digital tools, bring it to life, help make proactive decisions, essentially. The real big one here is the net zero materials, how we stay at the cutting edge of material development, what's happening in the key material markets. I show the picture right down at the bottom here is a trial going on in Sweden. Sorry, you should have made a bigger picture for you at the back. It's not a wonderful picture. It's an asphalt, laying asphalt on a road. But it's a bio-based binder. It's not a bitumen-based binder. It's a binder. It's a bio-based binder, which is interesting to see how that works over time. So it's on a 40-kilometre stretch of road in Sweden. We'll see how it performs over different temperatures and different traffic patterns and so on. We then got the fleet and plant challenge, a reliance on the combustion engine and the vehicles and the different ways we approach. And then kind of bringing it all together really is the supply chain collaboration, how we work together to bring these things to fruition, how we do make low carbon projects. So coming back to this emission challenge, this is a breakdown of our emissions over the time, over the last year actually. For those of you who can't see that concrete, the biggest area of our impact, this isn't by volume, this is by carbon emission. Okay, so as stated, we use hundreds of thousands of tons of concrete in a year, we use millions of tons of aggregate in a year, but the biggest impact once you take it together is steel. So you can easily break out the reinforcement, generally goes with the concrete, the structural steel, and then steel in general, which is across the materials and products we use. If you look around this room, the suspended ceiling, the raised floor system, the facade and everything that hangs off it generally has quite a lot of steel and steel involved. So our challenge comes down to 3 key parts: the combustion engine, how we use it, cement in concrete and how we generate that and how we do it, and then steel, how we make it, how we use it, and how we make the most out of it over time. Without dealing with those 3 things, construction is not going to be net zero. Just to sort of bring it home, and I know I don't have to labour it, but it is truly essential to what we do. Steel, it's, like I said, a third of our footprint, used in some major projects. This top one here is a major construction going on right now over in the City of London. This bridge is under construction now. In fact, it's being rolled in across the main line over a couple of possessions over the next few weekends. Even just from within the buildings themselves, and then also the temporary works, the things we use to support our operations, and that's before you get into the plant and equipment we use, before you get into all the mechanical and electrical plant and equipment that goes into buildings and construction. So overall, our key challenges relate to, we've got increasing interest and pressure. So increasing legislation, increasing expectation, and increasing client engagement and client want, if you want. We use high intensity materials and methods. Okay, so we have to be dealing with those. How we use them is generally in very long life cycle assets. So our decisions now are locking in carbon over time. And that's one of both strategy as well as build decisions. So we're either locking in life cycle implications, we're going to have to replace this very soon, or we're locking in use case scenarios, so the users of infrastructure or how infrastructure influences what we do. And another real key challenge of construction is the very, very segmented value chain. Extremely segmented value chain when you look at trying to drive innovation. In fact, I'm pretty sure the construction industry spells innovation R-I-S-K. Like, we tend not to like innovation and change because of the contractual nature with which the way the industry works. So very quickly on steel, we have increasing planning requirements. So for the City of London, for the Greater London Authority, we're being asked to put together early stage carbon appraisals of the projects we're doing and suggest how we're going to beat them. Contractual targets are developing. In fact, the NEC, which is one of our main contractual bodies in the industry, has just released an option for carbon and carbon reduction and management in contracts. And that has a performance table in it, which got a number of us scratching our heads as to how that's actually going to play out and what's that really going to mean between our clients and our supply chain, and how a carbon reduction performance target is laid out in a contract. We are project by project focused. So when you look at the demand signals you're probably going to get as producers, it's going to be, right, I now need net zero, please, because my next project is going to be net zero. That also has the effect of bringing blinkers down. It's difficult for us to see strategically because we're incentivized by the next contractual target. We are on the hunt for the lowest carbon materials as those contractual things come in. We need information to justify that, supplier EPDs and all those wonderful things that probably have you pulling your hair out. The things we need to be driving is increased reuse. Reuse, particularly with steel, is eminently possible. It's just contractually difficult. It's difficult with warranties, liabilities, proving the stress and the strains the materials have been under over time, being able to hand something over with all the right documentation. But that is a key carbon saving there. And also increasing the opportunity to think about the deconstruction of the things we're doing. Think about the way materials are laminated together or fixed together. Think about how easily they can come apart to enable a large chunk of that reuse. There really is big opportunity in what was talked about earlier with the circular economy around the materials, particularly with a material like steel that can essentially be reused without much, or repurposed without much input and effort if thought about up front. So just to bring it to sort of close, we don't have a silver bullet. We don't have a simple, here's one thing we'll do to decarbonize. It's many actions on many different layers across our company. Collaboration is critical. We can't do it all alone. We do need to influence our clients and the supply chain. But something I always bang on about to particularly people in the company and people younger generations as well is this is a really exciting challenge we have ahead of us for our industry that hasn't really changed that much over time. When you look at the way we've used materials, I'm not saying the materials themselves are going to change, but the way we use them is going to change dramatically. It's going to have to change. The methods by which we use them, the ways which we design with them, the ways we prolong their life, allow for their reuse, is going to change dramatically. And I think it's one of a really exciting place to be for the future. So thank you.
Thank you, David. And we have 20 minutes of Q&A. So can I be really cheeky then if we've got 20 minutes of Q&A? Because to me, all three speakers, they were all excellent, and actually their presentations, because we made them be really brief, raising more questions really than providing the answers, which is fantastic. So can I be really cheeky and ask questions of the speakers before I open it to the floor? And rather than show who's my favourite, I'll ask a question to each of them. So, to Cameron, in the move towards net zero steelmaking, which challenge is the UK uniquely capable in solving rather than other countries? Then I'll ask Jose. Jose, in the change in metals supply chains, metal supply chains, how they change, what role is there for three things: the steel sector, the metals recycling industry, and for government? And then finally, David, well, I'm going to kind of slightly ask two questions, because I want to ask you if there's a need, what do you need from government policy to support your objectives that already isn't there, because there's a lot there that supports your objectives in terms of government policy, but also how are you going to do it and remain competitive in this very fiercely competitive environment? So I've asked them in that order. Are you able to respond in that order?
Have a go, haven't we? So where is the UK uniquely placed from a steel decarbonisation perspective? So what's going to make it harder? I'm going to start there, and then I'll give you all the positives if you want. What makes it harder is that a lot of the infrastructure that's in place to process steel at the moment is not necessarily 100% geared up to producing the next generation of products. Some of it's coming towards the end of its life as well. But then you could also look at that as an opportunity, because you can say, well, these investments need to happen anyway, and we're in an ideal place to be able to make investments and change faster than countries that have less mature steel industries that have a lot of capital to write down on their assets still. So we're actually potentially in a good position in terms of transitioning to new technologies, because the investments have to be made come what may. Yeah, that's the first thing. In terms of what's unique about our own economy, it has to be the fact that we have an excess of available scrap. Yeah, and globally, if there's a 1 billion ton deficit, that puts the UK in a very special position. We don't quite realise how special that position is at the moment, clearly, because we haven't increased the scrap intensity of our steelmaking to what we could have done. I think I made the mistake of talking about exclusively about that within the context of the EAF, but I mean, there are also significant opportunities to increase that via the integrated route as well. But we're exporting about 8 million tonnes a year. Yeah. And of scrap. And I think the thing to think about there is that that has an impact on how much decarbonised steel we can produce, yes, but it also reduces the economies of scale that we have for all of the other stuff that we desperately need that happens to be in those waste streams. And Jose can comment on that in detail more than I can probably. But there's a lot of those critical high value materials at low concentrations that don't make any sense to recover unless you want to go after hundreds of thousands of tonnes, millions of tonnes a year of all of the other stuff. And that's what the steel industry can do. So we're very uniquely placed to be able to lead on the circular economy because of our abundance of raw materials that are coming to end of life, because we're a developed economy. Okay. And the last thing to add to that, just to give everybody else a chance, is that we're doing pretty well on the decarbonisation of our electricity supply. Massive regional disparity, but we're doing pretty well on a global benchmark. Great. So we're in a nice position for electrification of some of our processes.
Okay, thanks, Cameron. Jose.
Right. I think your question was about the roles of the steel sector, the recycling industry, and the government in changing the supply chain, essentially. Very different perspectives from each. Yeah. And I think for the steel sector, I think the key thing is to try and produce higher quality goods from scrap. We tend to produce stuff for the buildings industry, which is more tolerant to contamination. And I think the steel sector should probably be thinking about producing sheet as well from scrap. And I think the only way to do that is to actually cooperating more with the recycling industry and try to, instead of, for example, disassembling cars by grinding them down and joining all of these different metals together, we can think about more of an assembly line in reverse where we're carefully taking each piece apart, and then we're keeping the quality where it is, and then it's easier to then produce higher quality goods. And I think for government, I think it's key. I'll just reinforce the point that we need to think about consumption emissions more rather than just territorial emissions. And there needs to be some regulation that prevents this export of scrap, which is an incredible value, a very valuable raw material. I think we all agree on that.
Thank you, David.
Cool. Actually, from government, like you said, there's an awful lot going on at the moment, and I think, to be fair, it's probably more of the same. I know there are things that can be done, but there is effort happening to improve the focus. However, underneath that, so I won't let it off completely, but there does need to be a focus on materials and an understanding of the bigger strategic implications of some of the things that we're going. I mean, we were talking earlier as a group. This implication of all the scrap being exported is, if I'm hunting for an EPD for the lowest steel product, it could be made with UK scrap that's been exported to another market, which I'm then buying in because that had the lower impact of the thing. So if we're being incentivized to measure carbon in that way, which we have to have a focus on for reducing the footprint of the things we make, but we also have to understand the implications of some of the things we might be driving with the market. So I think strategic approach to materials would be something I'd ask from government around the construction and the potentials of its use. How do we remain competitive? Well, that really depends on how value and what the client conceives as value is dictated. Now that again is changing a bit. There's obviously a whole range in the market, right? So I'm not going to pretend it's all great, but it's not always lowest price wins. And the increasing pressure that say on certain organisations we work for to demonstrate they are reducing the carbon footprint and understand the implications of what they're doing is raising in importance, and it's increasing in the significance of how jobs are won and how that then translates through. So we're not always fighting for the lowest price, I think is what I'm saying there. There is a growing understanding that the industry, via the way it spends money and the signals it sends, can have a supporting effect as well.
Excellent.
Granted, I do have to say, we have to win a job to change a job. So we've got to fight in this competitive world, and we have to remain on that cutting edge. It means we can't do everything strategically. It's frustrating.
Okay. Questions from the audience. We have one microphone or two. We've got one. Yeah. So Frank's got a microphone, and then somebody right at the front, right near Frank. So, but there were two more, three more, four more, five more. Oh, okay.
Hi, Mark Davis from Tata Steel. I think probably question for Cameron, looking at this slide in terms of carbon options for decarbonising across the steel industry. The other dimension here is time and the time taken to execute. So we're sat on some sort of aged assets, as you rightly say, coming towards end of life. So the need to make a decision gets ever more important. So my question, I guess, is when you show your options, there's only one in the centre that looks to me like it's available on a shelf to actually use, whilst lots of work is going on other options. Carbon capture, have we yet seen any examples in industry in an integrated sense of someone using carbon capture, or anyone that is close to actually trying to do carbon capture in an integrated setting?
I'll have to qualify that I'm not an expert on carbon capture, but I could, I'm going to answer the question, but I could refer you to both Peter Styring at Sheffield University, who provides really useful advice on that, and Enrico Andreoli at Swansea University, both of whom I can put you in touch with to get a really detailed answer. The answer, as far as I understand it, is no. From a steel making perspective, is no. Yeah, if you look at where the most advanced, largest installations for CCS in particular they're actually being used to pump more oil and gas out of the ground. Yeah. So the options where we seem to feel people see a real benefit to using CCS seem to be in scenarios where they can use that to liberate even more fossil fuels. And the big examples of that are from the US. So there aren't huge examples of it being done. Nevertheless, the prices vary from estimate to estimate. But if you just looked at whether or not somebody will want to pull the trigger on doing that for a blast, for an integrated site, then you get variations in terms of what that means for price per tonne, but it might be £50 to £100, something like that, depending on which technologies you use and what your OPEX is and all of that sort of stuff. That's actually nothing in the context of the swings that we've seen in steel prices lately. But if you're the only one to do it, then whatever the market is, you're making less money. I think that's the problem. But there aren't any large-scale implementations of this technology for steelmaking at the moment.
Just very quickly, I'm not sure exactly the timescales, but Heidelberg Cement have a plant in Norway, which I think is piloting, and I think they have a program for using carbon capture and storage on the cement manufacturer, which is another material with a very similar problem. You've got the energy source and the chemistry of making the material, so carbon capture and storage is the only answer there, really, as well.
And then, thank you. Then, Frank, what we should try and do is take two, and ideally if it's for two different people on the panel.
Frederick Cheng from SGS. For Cameron, you mentioned passporting, so tracking material, raw or semi-finished material.
Mm-hmm.
How do you see that happening practically?
And then, sorry, let's take another question, ideally not for Cameron.
Just a comment. I'm Sergio Joannou from PCL Ceramics, and we've seen some interesting presentation from BCC on carbon capture and manufacturing of bricks. So I could directly to some people in BCC for that if you're interesting. So that was a question from Cameron as well. Still as a service, you had a slide on that. Obviously, we are a capital equipment manufacturer in the ceramic industry, and servitization is a big trend for us. So do you have any application or any producers which are trying to do this, so still as a service?
I guess I'll try and answer them really, really quick. Is that all right? I'm trying to remember what the first one was now. So I'll answer. You remind me of what the first one was. I'll answer the second one first, okay? So there are examples of where people are trying to vertically integrate their supply chains. Everybody has to do it, actually. So it's going to happen sooner than we can possibly imagine. I think there's going to be a steady transition. So at the moment, there are customer-focused elements of the steel supply chain. And then, as David has pointed out, there's people looking at their own material supply chains who are users of steel. An example that I'm aware of right now that will become more prominent is the fact that British Steel and Rail within the UK, and Network Rail in particular, are working closely together on how they can look at the performance of their products in service and maybe even get to a point where the rail's never actually sold. Yeah. So that's a very quick answer to that one.
And just to repeat what your question was, sorry.
Yeah, how's it going to happen?
How's the material passporting that you were mentioning?
Yeah.
How could that happen?
So there's two things that need to happen. One of them's kind of already there. The first one is that you need to have the standards in place to make sure that the data is formatted and regulated in a sensible way and done the same way by everybody. Yeah, there are actually standards in place for the data structures themselves without going into too much technical detail. So the data structures themselves are already covered. So there are common ways that we can interrogate and access the data in a sensible way. How are we going to make sure that it's uncorruptible? The answer to that is cybersecurity and the blockchain.
My question was more related because that's fine, that's all on the digital side. But
Yeah.
how do you attach that great data, which is uncorruptible, to a piece of metal or sheets or rope or whatever?
Yeah. So the same way that inventories are managed at the moment. So it is actually possible to trade. If you think about, we set in the steel industry, for example, we might set a stock of material 30 tons at a time. So we'll kind of define the properties of material, say 30 tons at the time. If you look at the strip business, for example, now that might go off everywhere, but it kind of all has the same, it's going to have pretty much the same information all the way across that material. So you can look at it on a batch by batch basis. A lot of this material is actually tracked because I work closely with the steel industry all the way to the point at which it leaves the steel manufacturer. The question is then making sure that it survives the journey for the rest of the way.
So, excellent. I was going to say Frank, more at the back. I know you saw some hands, so ideally 2 or 3 questions, not for Cameron.
Hi, good afternoon. Kamal Rajput, Tata Steel. I think it's a question for David. Have Skanska thought about buyback schemes for steel, which is very similar to the comment Cameron made about Network Rail and British Steel? So we're thinking about that, but is that obviously you're driven by client needs? Is there an opportunity to think about sort of a particular project and how that could be possible? So you never actually sort of, it's a new business model for steel producers.
Okay, and another question, please. Thank you.
Thank you. Patrick Heskins from the British Aerosol Manufacturers Association. I have a specific question about packaging steel. So this might be one for Jose to think about, is the carbon impact of packaging steel. I appreciate it's a relatively small part of the overall use of steel generally. But we are having lots of discussions. A lot of steel packaging is single use. Certainly for us in the aerosol industry, we are mandated by regulation to be single use. It's how we break the cycle of the make, use, dispose model and how we can get manufacturers who at the moment are very happy with the business model they have, making products and selling it, to look more at reusable, refillable, rather than just recycling as the route back through the circular economy.
Right. Should we keep it at that, or should we have one more question, if we can remember what those questions were? Let's keep it at that for the moment.
So the reuse of steel, it makes perfect sense. The challenge is the ownership and actually who should receive the value, if you like, or look after the value. Take the life cycle of commercial building, it's sort of developed by a developer who then employ contractors to do it, and then they look to sell it on for an institutional investor who might then use different tenants and so on, and then they will sell it on to a developer who's got an interest in the site for its future development. So it's breaking into that in the right place, which I actually think needs a little bit of legislative push or a planning signal to say, right, how are you going to demount this building? So it doesn't need, particularly high-rise buildings, it should be a very careful consideration, because when they do come down, that is a problem, you know, how they're going to be demolished. And how are those materials going to be either tracked through their life, so you know what they are, because what would be ideal is that they're repurposed and reused, because in many cases they're well within their performance criteria because of risk and how that's passed through. And yeah, they could often be directly recycled through. So there isn't one necessarily for Skanska to take on because of the way the industry's structured at the moment. But you know, that as that thinking comes round, with a bit of legislative push, I could see opportunity there.
And then the metal packaging one, were you able to answer that, Cameron? And if you weren't, or are
It
you?
was fired at Jose.
Oh, was it Jose? Sorry.
Yeah.
I was going to say.
That's okay. I can try. I'm not an expert on packaging, and
I was going to say, what I was going to say is there's lots of people from Tata in the audience, and therefore they might not want to stand up and give you an answer in public here, but actually they might approach you after this session. Sorry, Jose.
yeah, I can try to. I think the question was, how do we get rid of single-use metal packaging, basically, or the question was that, and the honest answer is I have no idea how to do that, but we have calculated how much metal actually flows into packaging, so we know the environmental benefit of that. And within our report, we actually also estimated the business opportunity from getting rid of all single-use plastics, and it's in the hundreds of millions actually to replace that single-use goods with reusable options, and that's for all materials, not only steel. And I think steel is quite nice because it's easily recyclable, but there's very big issues within plastics, for example, where a lot of the packaging actually is not recyclable. So the short answer is, I don't know, but we have estimated how much money could be made from solving that problem.
So we've got a couple of minutes. Should we take, if there are 2 more questions, we could take the 2 more questions. Oh, there is. And then we'll wrap up, and then you'll have to all run to the next session.
Hi, Bill Farrell from Heidelberg Defence International. I mean, we actually use steeling for gun barrels, which is probably slightly different than most people here. But my question actually, or the scariest slide I saw in the whole 3 presentations, related to the renewable energy that we were going to be generating in 2045 or 2050, which would appear to be 50% of what we're actually going to need. Given that I understand it, we have the best wind potential of any country pretty much in Europe. We have geothermal potential in places like Cornwall and the Lake District. We cancelled 3 tidal lagoons off Swansea, or at least I believe our friend Mr. Hammond, who was then the Chancellor of Exchequer, pulled the 3 billion, which would have allowed it to go ahead, which was less than 1% of what we spent on the pandemic, you know, in context. He also cancelled the carbon capture storage, which was 1 billion for the company that could come up with a working solution. And I think there were 2 or 3 companies that were on the case. And I almost feel like...
Try and get to the end of the question so we can get an answer to it.
I almost feel like I should be giving this question to Kwasi Kwarteng, to be honest. Come on, you need to do better. If you're really serious about the outcome of COP26, you guys are at the forefront of understanding just how big the gap is. Do you see anything coming from the government which is actually going to really jump on that? Because to me, that is probably the biggest challenge we face in the next 25 years.
And then was there one more question? Is it a quick question? Was that? Oh, yeah, that was it.
Hello.
And then there was one. Go on.
Arjan Geevke, EIUG. Question for Cameron as well, unfortunately. You mentioned product passport inventory. From your perspective, who should own and manage that?
Great. And then, James, you had your hand up. Was it a comment or were you going to ask another question? Oh. Yeah, quick. No, let's answer them and then we'll end with that then.
Yes, it's a question for Gareth in terms of Mark mentioned, and I think you went through some of the assets at the end, coming up to the end of the life cycle, and then you've got some large capital investment in terms of a technology solution. What's the stance currently? Because I was going to ask the gentleman, the minister early on, but he only lasted 20 minutes. What's the stance of the government to try and fast track some of those future technologies?
Answer the questions and I'll try and answer that one.
Okay, I'm trying to remember what the first one you gave us.
First one was about the speed of government action and is there enough? To be perfectly honest, with the materials are key challenges. There's starting to show signs of electrification, although that won't be the only answer with plant and equipment. We will need hydrogen. I don't see enough for carbon capture or the focus around material hubs and making those things in combination. So I don't see enough of that.
And then as we're losing people very quickly because they need to rush off, Cameron, the passport ownership bit.
I see it vesting with the materials producers.
Okay. And then let's be really positive about government, especially because we have 2 very important government officials in the room. So actually, I see in the last few months a real change in terms of government and understanding, and from the Prime Minister down, of understanding the steel sector and foundation sectors like steel, and deciding, yeah, we need to do something about the steel sector rather than just keep sticking plasters on it. And so, from my point of view, going forward now, looking forward into the future, I actually think the government gets it more now than they have done for many, many years.
The challenge would be that platform's been burning.
Yeah, and it's a difficult...
And we're at the point of decision.
Yeah.
The Minister today certainly didn't like that, because it was an insult to all of us. We're manufacturing, and the Minister came with a speech that you open a fate. You know, it was patronising, and he couldn't take any questions. No.
I'm afraid I was preparing for this session, so I can't even comment on what the Minister said. But no, I get that, you know, and it's once that burning platform is burnt too much, you can't repair it. So it's a difficult one. But you know, we need to be really positive with the actions that we've seen on government and trade, on energy prices, but also on just in terms of understanding the steel sector's part in levelling up, and we haven't seen that for quite a few years. So
can I just chip in there? I mean, they at least talk about it now. You don't have to go back very far before they weren't even interested in talking about it.
Exactly. Yeah, I could have summed it up like that. So thank you very much. Thank you, to everyone. We've got to go because you're all rushing off. Thank you to the 3 speakers. Thank you all for coming. It's a really interesting conversation.